compiler completed. Yes, about Java discussed. So Java depending on both the compiler as well interpreter. So this topic completed. Okay. Now let us see about Java features. Java features. See here. We try. Yes, 9:30. See day 2. Yes, about Java discussed. Java. Yes, about Java discussed in this year. JDK 1.0 released with below features. So initial features: independent platform, portability, OOPS language, scalability, security. These are the initial features of Java. Okay, these are initial features of Java. Okay, these are initial features of Java. Okay, like independent platform, portability, OOP language, scalability, and security. Yes, guys, my voice is clear. Hello, my voice is clear. Can you hear me clearly? Okay, fine. Yeah, these resigning. No problem. Yes, yeah. Now these are the initial features. These are initial features of Java. These are initial features of Java. These are initial features. These are initial features. Okay. Yes. These are initial features of Java. Yes. To understand these features here, last two classes, yes, we discussed some basics. So what we discussed in last two classes, that's enough to understand this one here. Okay, basics. We have discussed some basics. Okay, to understand these features, I have covered some basics here. To understand these features, like voice, what is voice, what is interpreter, what is compiler, what is low-level language, high-level language. All that basics were discussed in previous classes. Here, that basics enough to understand these topics here. That basics enough to understand these topics. That basics are enough to understand these features. Now today let us say about these features. Independent platform. Independent platform. Okay, Java is independent platform. So what does it mean? Let us see. Yes, Java is an independent platform. See, Java is an independent platform. Yes, what does it mean? What does it mean? Java is independent platform. Java is an independent platform. What does it mean here? What does it mean? See, here platform means OS. Here platform means OS. It's a OS. Platform means OS. Platform means OS. Platform means it's a OS. Platform means operating system. Platform, see, previously discussed. OS is a platform. On top of it, everything is running, right? See, at the beginning classes we discussed. Beginning classes. See, hardware. On top of hardware, there's a OS. On top of OS, all the application software is running, right? On top of OS, all these are running. Okay. See, OS, it's a platform. It's a platform. Yes, it is a platform where we can run all the application software. So OS acting like a platform. It's a platform where we can run all the application software. So OS is a platform. A platform means OS. Okay, Java is independent platform. What does it mean here? Platform means OS. Okay, that means here Java program, yes, can run any operating system, can run on any operating system. Okay, Java program can run on any operating system, any operating system. Okay, Java program can run on any operating system. Okay, so Java program can run on any operating system. Java program can run on any operating system. Okay, Java program can run on any operation. That's the meaning of independent platform here. Okay, so Java is independent platform means here, yes, Java program can run on any operating system. Java program can run on any operating system. Okay, yes. Yes, now question is here, how Java program, yes, made us independent of platform. How Java program made us independent of platform. Yes, interesting topic. This is, yes, very interesting topic. Yes, how Java program made us independent of. Yes, how Java program made us independent of platform. Yes, to answer this question here, yes, you must have some exe file knowledge. Yes, about exe file, about dot class file. You must have, yes, knowledge of exe file, about exe file, about dot class file. Yes, dot class file. Yes, if you know that about exe file, about dot exe or dot class file. Yes, you must have that knowledge. If you have that knowledge, then easy to understand this one here. Now let us say about exe file, about exe file, about exe file, about exe file. Okay. So what is exe file? Yes, first question, what is exe file? What is exe file? Yes, exe file is a binary code file. Exe file is a binary. Exe file is a binary code file. Exe file is a binary code file. What is exe file? Means it's a binary code file. Exe file is a binary code file, and it is a system understandable language. System understandable. It is system understandable language. It's a system understandable language. Okay. Exe file is a binary code file. Exe file is a binary code file and it's a system understandable language. So exe file contains exactly what is exe file? What does it contain? Let us see. See, some question for you guys. Some question. The exe file prepared on Windows OS. Exe file prepared on Windows OS. Okay, for example here, yes, exe file prepared on Windows OS. Can I run on Linux OS? Can I run on Linux OS? Exe file prepared on Windows OS. See, exe file prepared on Windows OS. Can I run on Linux OS? Yes, there's a question. Exe file prepared on Windows OS. Can I run on Linux or any other operating system? Can I run on other operating systems here? Can I run on other operating systems? Yes, answer is here. No, we can't run. No. Reason. Exe file. Exe file is a OS dependent. Exe file is OS dependent. OS dependent here. Exe file is OS dependent. Reason exe file. Okay, is a OS dependent. Yes, reason is exe file is a OS dependent. Okay, immediately question, why exe file is OS dependent? Why exe file is OS dependent? Why exe file is OS dependent? Yes, come on, Amjad. Why exe file is OS dependent? Okay. Yes, Mr. Amjad. What you said is right. Okay, fine. Exe file is OS dependent. Okay. If exe file prepared on Windows space, running on only Windows space, if it is Linux prepared, only Linux space. It cannot run on it can't run other applications. What's the reason? This is important. So here anyone says, any trainer, any website simply says that exe file is dependent, but reason they can't explain properly here. Okay, they can't explain properly what's the reason exactly here. Yes, to understand, yes, for this purpose you must have exe file knowledge. Okay, so exe file contains what? So what is exactly exe file? Exe file contains what? Okay, suppose for example here, yes, let us take C program. Yes, C program exe file, C language, C program exe file prepared on Windows OS, prepared on Windows OS, then it contains what? It contains what? Yes. Now let me show that C program. Yeah, this is C program. Okay. Yes, here C program. Yeah, this is a math.cpp. Math.cpp. It's a C program. So compile success. Yes, run it. No errors. Executing 10, 20. Yes. So outputs. Yes. 30 minus 10, 200. 30 minus 10, 200. 30 minus 10, 200. Okay. Now what happens? Let us see back end of this turbo C. Back end of turbo C. C drive, EC, EC, bin, math. See math. Let me delete that existing files. Delete that old files. Deleting. Okay. Deleting. See, in yesterday's class we discussed compiler generates exe file. Same topic now. Alt C compile. Compiles. When compiled back and see this. Some math. Here some file generated. Some file generated. Okay. Some file generated. See, object file. Right? What is this object file? This object file contains binary code for C program. This C program, your C program binary code. C compiler convert this whole code into binary formats and write to this object file. Write to this object file. Now run this. When you try to run it, yes, exe file created. Exe file created. Exe file created. Yes, how that exe file generated here. Now what happens here? C compiler taking binary code for C program means math.obj, this obj file, dot obj object file, dot obj, it's object file. This object file contains binary code for C program, binary code for C program. Now compiler taking binary code for this C program, binary code for C program plus binary code for C library. stdio data set file convert data. They are predefined library. This predefined library also having its own binary code. Predefined library also having its own binary code. Okay, this predefined library also having its own binary codes. Now compiler taking binary code for C program means that math.object file plus next taking this one here binary code for C library and binary code for OS library. Yes, in OS also there is a library here. In OS also there is a library. See, in OS there is a library. So in previous class here there is library. In OS there is a library. Library to perform IO operations. Okay, OS library to perform IO operations. IO operations. Okay, so here this OS library. So that OS library, by linking all of these things generates exe file. By linking all of these things generates exe file. C program exe file prepared in Windows space, then it contains binary code for C program. Yes, binary codes. Yes, it contains binary. Yes, binary codes. Binary codes. Binary code for C program. Binary code for C program plus binary codes for C library. Binary code for C library. Okay, binary code for C program, binary code for C library. Okay, next binary code for OS library. OS library. Now it's a Windows OS. Here running on Windows OS, exe creating on Windows OS, Windows OS library. Windows OS library. Okay, by linking all of these things generates exe file. Finally, exe generating here by linking all of these things. Binary code for C program. Yes, binary code for C library, binary code for OS library. By linking all of these generates exe file. That is exactly exe file. Okay, linking all of these things here. Okay, see previous in OS topics we discussed. OS topics. See, every program has to link with OS library before going to run. It has to link. Every program has to link with OS library. OS library. So in C language, what is happening here? Compiler, what is happening here? That library linking with exe file. Yes, at exe file creating itself here. At the time of creation of exe file itself, linking with OS library here. See, C program exe file prepared on Windows OS. Then binary code of C program, binary code of C library, binary code of OS library. By linking all of this, it generates exe file. That means OS library included in the exe file. OS library also included in the exe file. Let us take one more example. Linux OS. Yes. Now you can understand that exe creation you can understand clearly. In Linux, practically we can see. In Linux, you can see practically. See Windows based Turbo C backend that exe file created. Yes, in backend everything happens Windows based. In Turbo C, it's IDE. In this IDE, backend happens here. Everything happens in the backend. When come to Linux, we should create manually all of these things. We should create manually. Demo login. Yes. See, present working the Linux present working a home demo, ls its contents. See, mn drive is a directory, cd mn drive, change of directory mn drive. Yes, you guys don't think about Linux base. Our topic is not about Linux base. Our topic is about exe file. Okay, see, in Linux, I'm using some commands. I'm using some commands. You guys don't worry about commands. Our topic is not Linux commands. Our topic is about exe file. pwd, present working directory, mn drive, ls, its contents. Okay, one second. Let me remove some files here. Restart. See, test.c program. zrich test.c. Same with addition, subtraction, and multiplication of two numbers. Okay. Yes, C program. Here also library included. stdio data set of included. Addition, subtraction, multiplication. Okay. So this is your ls list of files. Test.c file. Now we should compile it. cc-c test. Now here manually compiling. Test.c compile, no error. C means compile. C means C language compiler. C means C language compiler. C first is C language. Next is compile. C language compiler. Hyphens mean only compile option. Just only compilation. Only compilation. Now see that result file. Test.o file generated. After compilation, result is test.o. .o means object file. That object file created like Windows. Windows math.obj file. obj for that object file. .obj object file created. Object file in Linux are same object file created. Now this object file can be bind code for your C program only. Bind code for your C program. That's it here. Now let us create exe file. cc-o. Yes, project name of exe project here. Test.o. Yes, -o means linking object files. Linking all the object files. Linking all the object files. Generating project exe. This name can be anyone. Project exe. Okay, let's. Yes, now what happens? Can of C language, C language compiler taking test.o means binding code for our C program plus binding code for C library stdio data set file and binding code for this Linux based library. By linking all of this in generates exe file. That project exe. So this project exe file contains that project exe file. Now let us run that project exe file. Project exe file. Yeah, that ex name can be anyone here, not any projects. Suppose name. Suppose some ABC. Yes, it can be ABC also. It can be ABC. /ABC. ABC. Right? Addition, subtraction, multiplication. That's it here. Okay, right? So exactly what is that exe file? That exe file. Okay. Exe file. How it's creating here? Exe file. Yes, C compiler creating exe file by linking. Yes. Binding code for C program, binding code for C library, and binding code for Linux based library. By linking all of this generates the project exe file. Okay. Now C program exe file prepared on Linux based, then it can bind code for C program, bind code for C library, bind code for Linux based library. By linking all of these generates exe file. By linking all of these generating exe file. Okay, see, let us see that exe file. Let me show the exe file. Project exe file. Project exe file. Yes, opening. Just take a little bit time. Yes, see this exe format is like this. Binary code. System understand machine language. It's a machine language. Exe format is like this. Exe. Okay. Exe format. See in Linux they say file command. Linux they say file command to check the type of the file. See test.c. Yes, what is the file command checking? What's the type of test.c? Type of testing. Test. It's a C source ASCII text. It's a C program source and ASCII text. ASCII text file. It's ASCII text file. C source file. Okay. Next file. The projects. What is project? See that exe file. Executable file. Executable file. File command checking type of that file. Project. It's a executable file. Okay. Here x86 86 means 8086 processor. Yes, in my system using 8086 processor, 64-bit OS, 64-bit OS. Okay, right? Yes, these are hardware information. Exe file, hardware information. Next, see this. LD-Linux x8664.so2. What is this? It's a Linux OS library. .so. .so. It's extension for OS library. It's extension for OS library. So this is Linux OS library. So Linux OS library inside of project exe file. That project exe file contains what? That Linux OS library. So OS library linked with project exe file. Okay, right? I think it's clear here. Actually, there are embedded C language concepts here. Embedded C concepts. Embedded C concepts here. Okay. Yes. So Linux library also included in project exe file. Okay, so finally, what is exactly exe file? So exe file contains yes C program, yes prepare a Linux base, then it contains yes binding code for C program, binding code for C library, binding code for Linux based library. Let us take one more example: C++ code, C++ program exe file, C++ program exe file prepared on Windows base, prepared on Windows base. Then it contains binary code for C++ program. Next binary code for C++ library. Next binary code for Windows OS library. Windows OS library. By linking all of this, it generates exe file. That's it here. Now what is happening? These three cases. What is happening commonly here? These three cases. What is happening commonly here? Yes. First case. Windows library linking with exe file. Second case, Linux library linking with exe file. Third case, Windows library linking. So commonly what is happening here? That library linking with exe file. Okay. So here what happens? Exe file, exe file always. Yes, exe file. Where is anyone here? Exe file always links with OS library. OS library. Okay. Yes, exe file always links with OS library. That's it here. Okay, here. Yes, now what happens here? Yes, now OS library. See, at the time of generating exe file itself, OS library links with exe file. See, OS library, library. Yes, links with exe file. OS library linking with exe file. At the time of generating exe file, yes, it is called as static linking. Yes, at the time of creation of exe file linking, it is called as static linking. Statically linking is called as Called as statically linking. Statically linking. It is called as statical linking. It's called as statical linking here. So OS library links with exe file at the time of generating exe file. Okay, at the time of generating exe file itself. Statical linking. Statically means fixed. Dynamic elements changes. That link changes. Suppose if it is linking at runtime, that is called dynamical linking. Just wait. Once dynamical linking clears, you can understand statical linking also. What is exactly statical linking, dynamical linking? We'll discuss. Next 5 minutes getting same topic here. Statically, dynamic, the differences. Okay. Yes. Now what happens here? So here exe file. So exe file always links with OS library. Okay. Suppose for example here test.exe files. Test.exe file prepared on Windows OS. Test.exe file prepared on Windows OS. Then it links with yes Win OS library. Win OS library. Test.exe file. Test.exe file prepared on Windows OS. Then it links with Win library. Okay. Now test.exe file. Yes, with exe file with the Win library on different operations. Test.exe file with Win library working on different platforms or operations. Okay, let us take different platforms here. How it's working? Different platforms. First, let us take Windows platform. Windows OS. Okay. Hardware. On top of hardware, OS will be running. On top of hardware, this OS running, right? OS. On top of hardware, OS running. Yes, operating system. Operating system running. On top of hardware, OS running. On top of hardware, OS running. Okay. On top of hardware, OS running. Operating system running. Okay. Yes. On top of OS, now running your C program. Yes. Let us say Windows OS. Yes, Windows OS. Windows OS with Win library. Windows OS with Win library here. Windows OS with Windows library here, right? Now test.exe file. Okay. So test.exe file with Win library running on Windows OS. Yes, now it's working here. Test.exe file. So when you try to run test.exe file, see test.exe file with Win library. Test.exe file with Win library. See test.exe file prepared in Windows OS. Then it links with Windows library, Win OS library. Okay. Now test.exe file with Win library working on different operating systems. Just let us see. Now test.exe file running on Windows OS. So when you try to run test.exe file, now test.exe file it makes a call to Win library. Because reason here test.exe it try to call Windows OS library. See test.exe file prepared Windows OS that links with Windows OS library here. That means Windows OS library plugged into exe that plugin into exe file. That will plug into exe file. Means it's one part in the exe file. That library goes to exe file. Windows OS library plug into exe file. Just a plugin means that Windows OS library becomes part of exe file. Okay, when you try to run that exe file, yes, it makes a call to Windows OS library. Since test.exe file linked with OS library, Yes, it will try to call to Windows OS library. Here test.exe file, test.exe file. Since test.exe file linked, test.exe file linked with Windows OS library. Yes, it will try to call Win library. It will try to call Windows library here. Yes, it will try to call Windows library. Yes, available. Same library available here. Then using that library communicates with the hardware components. That's it. Working here. Fine. Okay. Test.exe file. Yes, it will call to Windows library. Yes, available. Then execute successfully executing. Let us take another platform. Let us take another platform. Another platform. Another platform. Yes, Windows. Next, Linux base. Let us take Linux base. How that Linux base is running here, working here. Not test.exe file. Okay. Yes, here also test.exe file. It tried to call to Windows OS library. This also tried to call to Windows OS library. 1 second, let me have some water. Yes. See here also the test.exe file. Test.exe file. Yes, it will try to call to Windows OS library because test.exe file already linked with Windows OS library. That is fixed. Already it was plugged in. That library was plugged in into exe file. Okay, so always it will try to call same library. On Linux OS also, a Linux OS with Linux library, Linux OS with Linux library. Okay, on Linux OS also it will try to call Windows OS library, but here is not available. That library is not matching, simply fails. Test.exe file here it fails. It fails because library is not matching. Test.exe file linked with Windows OS library, but current OS is Linux library. Library not matching. Since not matching fails, it fails here. Okay, suppose Mac OS. If it is Mac OS with Mac library, Mac OS with Mac library, Mac library. Here also same thing happens here. Test.exe we try to call to Windows OS library. Okay, it will try to call Windows OS library, but here is not available. Mac library. That library is differing. Simply again fails. Again fails. That means exe file prepared on Windows OS running on only Windows OS. With other operations cannot run. Reason? Yes, exe file contains OS library. Okay, exe file contains OS library. Since exe file linked with OS library, it's a OS dependent. So this is OS dependent, right? It's OS dependent concept is like this. Okay, test.exe with Windows OS library. It will try to call Win library. Yes, available here. Fine, working. Now here also trying to call Windows library, but not available. Simply fails. Here also try to call Windows library, but not available. Fails. Since library is not matching, fails here. Okay, yes, since exe file, yes, linked with OS library statically statically means that link is fixed, that link never changes. Statically means link is fixed, that link never changes. Since exe file linked with OS library statically, yes, it is a OS dependent, OS dependent, OS dependent, OS dependent. That's it here. That is about exe file. Now let us see Java dot class. What is Java dot class file? Now about Java dot class file. Okay, so what is dot class file? Yes, dot class. See, dot class is a bytecode file. Is a bytecode file. Dot class a bytecode file. Bytecode file. And it's a JVM understandable language. It is a yes, it is a JVM understandable. JVM understandable. This is JVM understandable language. So Java dot class is a bytecode file and it's a JVM understandable language. Now same example let us take for Java dot class also. Like C programming here also. Let's take same thing here also. Java. Yes, C program exe file. Place of this no Java. Java dot class file. Java don't have exe file concept, dot class file. Java dot class file prepared on Windows OS, then it contains what? Yes, it contains what? Yes, in case of C, Java. Right? Binary code for C Java program? No, it's a byte code, not binary code, byte code. In Java, everything is byte format. In Java, yes, the Java dot class file contains always byte code. Okay, that byte code later converts into binary format and executing. Okay, before running, the dot class is byte code format. Byte code format. The byte code format converts into binary code, then executing. Yes, byte code for Java program. Next, byte code. Next, byte code for Java library. 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 Next, binary code for OS library. No, don't have that part. Don't have that part. Okay, so byte code for Java program, byte code for Java library. That is dot class file. So what is Java library here? What is Java library? So what is a Java library? Java library also developed in Java. Java library also developed in Java. C library developed in C language. Python library in Python. C++ library in C++ language. Java library in Java language only here. That means here it's a pure Java program. So dot class file. So yes, see, byte code for Java program, byte code for our Java program, byte code for Java library. Java library also in Java. That means pure Java program. So dot class file. So dot class file is a pure Java program. Is a pure Java program. Is a pure Java program. So dot class file is a pure Java program. Okay, pure Java program. Yes, yes. It don't have any OS library. Don't have any OS library. Dot class file don't have any OS library. Yes, it is free. It is free from OS library. OS library. It is free from OS library. So dot class don't have any OS library. Dot class file don't have any OS library. It is free from OS library. Okay. Suppose for example, get tested dot class. Tested dot class. Okay. Yes. Prepared. Tested dot class are prepared on anyways. Okay. Anyways. Yes. Dot class file prepared dot class. Tested dot class file prepared are anyways same. No change here. No difference. Anyways same here. Dot class prepared are anyways here. Okay, but don't have OS library here. But don't have any OS library here. Okay, any OS library here. Don't have any OS library. Same. Yes, dot class file is same or for every ways. So dot class file is same. Dot class file is same for all operating systems. Is same, no change here. All operating systems. Okay. Yes, for all operating systems is same here. Same for all operating systems here. Right? No change. Okay. Yes. Tested dot class are prepared anyways here, but don't have any OS library. No OS library. Dot class is same for all operations. Okay. No. For example, tested dot class file working on different platforms. Test dot class file working on different platforms. Yes, how it's working on different platforms here. Like exe file, test.class file. Let us see. Like exe file, about exe file in different platforms we discussed, right? Exe file in different platforms. Like exe file, how dot class file working on different platforms. Yes, let us take dot class file. Dot class file working on different platforms. So first Windows platform. So tested dot class file. Okay, so you get tested dot class file. So this tested dot class file placed on Windows OS. Now if I run this, what happens here? Now can I run this tested dot class file directly here? Can I run? No, we can't run test dot class file directly here. Reason here, See, yes, in ways we have discussed one point here. Right, recollect here. Every program has to link with Voice library. C program, C++, Java, and all the programs have to link with Voice library before going to run. It has to link compulsory. Suppose if it is exe file, C and C++ exe file already linked. Yes, in C and C++, exe file already linked with Voice library. At the time of generating exe file itself, Voice library already linked. So exe file is having Voice library. Okay, but when come to Java here, dot class file don't have any Voice library. Dot class file don't have any Voice library, but it has to link. This dot class file has to link with Voice library. Otherwise, cannot run here. Now running test dot class file directly. No, you cannot run here. You can't run because dot class file don't have any Voice library. You cannot run here. It has to link. This dot class file should be linked with Windows Voice library. Who will link it here? For linking purpose between test.class file and Windows Voice, one more layer come to picture. So between dot class file, yes, Windows Voice library, one more layer come to picture. What is that layer? Can you guess it? Yes, between dot class file and Windows Voice, one more layer come to picture. What is that layer? Yes, that layer is a JVM, Java Virtual Machine. Now JVM come to the picture. It's a JVM, Java Virtual Machine. Now JVM taking dot class file links with Windows Voice library. That's it here. So once linked here, then executes, then getting output finally. Okay. Yes. Next, let us take another platform. Linux platform. Linux base with the Linux library. Linux base with Linux library. Yes, how it's working here. Okay. See, same test.class file. Taking by JVM and links with Linux base library. Okay. Yes. If it is running a test.class file running a Linux base here, Linux JVM taking test.class file links to Linux base library. That's here. Once link completed, executes. Next, another voice. Suppose Mac voice with Mac library. Mac voice with Mac library. On Mac voice also JVM. Yes, Mac JVM taking test.class file links to Mac's library. Okay, so what is happening here? For every time of changing voice, link is changing. If tested.class file running on Windows Voice linking to Linux Windows Voice library, same test.class file if it is running on Linux base linking to Linux Voice library, same test.class file if running on Mac base links to Mac library. If it is running on Solaris, that links to Solaris Voice here. If it is Unix like that here. So every time of changing, that link is changing. This is called as what dynamical linking. Dynamically linking. Okay. So depends on ways that link changes here. Dynamical linking. Since dynamical linking, it's an independent platform. Okay. So every time of changing ways, that link changes. Changing ways, again link changes. Changing ways, link changes here. It's a dynamical linking. Okay. Yes. Since Java.class file dynamically dynamically linking with voice library. Yes, it's an independent platform. Yes, it is a independent platform. Yes, it's independent platform. Okay, dynamic linking. Okay, so every time of changing, that link is changing. So it's called a dynamic linking here. Dynamically. In C language, what happens here? See, at the time of creating exe file itself, linked with voice library here. Yes, at the time of creation of exe file, we itself links with Windows OS library. Okay. Yes, put a Linux library. Okay, at the time of creating exe file itself. Okay, exe file. OS library links with exe file at the time of generating exe. It is called a statical linking. At the time of generating exe, that link never changes. So once linked with Windows OS library, yes, always with Windows OS library only, that link never changes. Exe file, that link never changes. It's a fixed link, is fixed means statically. Statically means fixed. That link is fixed. Here statically. Statically means fixed. Statically means fixed. That link is fixed here. Okay. Yes. When come to Java, that link changing. Every time I'm changing ways, that link is changing, right? This is dynamically linking. Okay. So it is statically linking. Statically statical linking. Yes, it's a OS dependent here. OS dependent. Next, dynamically linking. Yes, OS independent, OS independent, OS independent here. OS independent here. Okay, OS independent here. See, any program, yes, which is any program which is dynamically, yes, linking with OS library, yes, is an independent of OS, is independent of platform, independent of platform, independent of platform, independent of platform. Okay. Yes, not only Java, even Python. See, Python also independent of platform. See, Python also happens same thing here. Python also links to OS library dynamically. Python also links to OS library dynamically. Okay, so Python scripting also independent of platform. That's fine. Now here, I hope you understand, guys, right? Independent of platform concept. Is it clear? How Java made us independent of platform dynamically linking. Reason dynamic linking. Since Java.class for dynamic linking with OS library by the JVM, So by the JVM, it's independent of platform. It's independent of platform. Okay, since Java.class for dynamically linking with OS library by the JVM, it's independent of platform. Now JVM takes care of making independent of platform. Okay, now here some doubt getting, definitely some doubt getting. Windows JVM links to Windows OS library, Linux JVM links to Linux library here, Mac JVM links to Mac library. That's okay, fine. Now JVM, is it part of OS? Windows JVM, I'm saying that Windows JVM, Linux JVM, Mac JVM, is it part of OS? No. JVM is not a part of OS. JVM, yes, is not a part of OS. It's not a part of OS. Yes, it is from JDK software. It's from JDK software. Okay, it is from JDK software. It's from JDK software. Yes, to get JVM, to get JVM, yes, we need to install. JDK. We need to install JDK software on system, software on the OS. Here. The JDK should be installed here. To get JVM, yes, we need to. So we need to install. JDK software on the OS. Once JDK software installed, getting JVM automatically. Once JDK software installed, then getting JVM automatically. Just getting JVM automatically. That's it. Okay. Yes. Next, one more interesting point here. See, Java.class file. Yes, is an independent. Java.class file is independent of platform. See, Java.class file is independent of platform, but JVM is a voice dependent. Reason Java dot class file is independent of platform, okay. But JVM is a voice dependent. That JVM is a voice dependent. Reason JVM developed in C++. That means JVM is a C++ exe file. Yes, C++ is always exe file. JVM is a C++ exe file. JVM is a C++ exe file. It's a C++ exe file. JVM is a C++ exe file. Okay, if it is exe file, why is dependent? That's here. Okay, here Sunsoft. See, Sunsoft has developed different JVM for different operations. Okay, yes, Sunsoft has developed different JVM for different operations. Okay, so JVM for Windows OS, JVM for Linux OS, JVM for Unix OS, JVM for Mac OS, JVM for Solaris. That's it here. Okay, see, suppose JDK software or Windows OS. The JDK must have JVM for Windows OS, right? JDK for Windows OS. Yes, should have Windows JVM, right? Okay, should have Windows JVM. Okay, so JDK for Linux OS. JDK for Linux. Yeah, that should have Linux JVM. That means here JVM different for different operations. So JDK Windows should have Windows JVM. JDK of Linux should have Linux JVM here. Yes, JDK for Mac OS, Mac JVM. That means JDK contents are changing here. JDK for Windows, its contents are what? Windows JVM. JDK Linux contains what? Linux JVM. That means contents are changing. That means JDK also is dependent. JDK changes. Same JDK cannot be installed on different operations. Okay. See, since JVM is a OS dependent. Since JVM is OS dependent. JDK also OS dependent here. OS dependent. That's all about independent of platform. See, same JDK cannot be installed on different operations. Suppose Windows, since my system C drive, Windows JDK 8 and 9. So 8 JDK, Windows JDK this cannot be installed on Linux base. This will not run on Linux base here. Okay. Yes, JDK downloads. See, Java software, Oracle Corporation. See, this is JDK for Linux. This is okay. Yes, Linux also we have different flavors. Linux also different flavors. Yes, next Mac OS. For Mac OS, Mac JDK. Solaris OS, Solaris JDK. Windows OS, Windows JDK. See the JDK changing, right? Yes. In our case, Windows 10 we have downloaded last one. This one we should download it. Last one we should download it. So Windows 64-bit OS, we should download this one here. Last one. Yes, you guys not necessary to download. Yes, it's there in Drive. In Drive it's available. Okay. Yes, I have shared Drive. I have shared to Drive most of students. Drive access given yesterday. Drive access given yesterday night. I have given even the same message shared in the group also. Same message shared in the group. See what Drive. This is Drive. Yes, my drive, Menda course here JDK 8, that Windows JDK 8 here available. Yes, your class document, updated document available. Okay. Yes, you can download from the drive. Yes, drive access given to most of students. Today morning I have given drive access for most of the students. Drive access given here. Yes, you can download from this. Okay. Yes, how to download? 1 second. Say I have given access like this. Share. I have given access like this. A member suppose to this. For example, this mail ID I am giving access. Send. So this material drive. Giving access on material drive. Yes, next recordings drive. Recordings. Your batch recordings. Yeah, this is your batch recordings. Recordings drive. Yes, 9:30 AM. Recording C. 1, 2, 3, 4. Totally 4 recordings till yesterday. Today's also I'll upload it here. Share. Yes, giving drive access. Same and the same. For same Gmail ID. Drive access giving the sense. Now drive access given to these two drives. Material drive and recordings drive. Okay. Yes, these two drives access given to the Gmail ID. Now login. Log into yes. How to access that drive here? Now log. First of all, you log into your Gmail ID. Log into your Gmail account. Log into your account here. After login into accounts, go to apps. Google Apps. Here there is a Google Apps. Google Apps. Google Apps. Here there is a drive option. Google Apps drive option. Open drive. Open drive. After opening drive here, please share it with me. 1 second. Not this time. Right. One. Yeah, this is. See, Google Apps. Yes, now share it with me. Here Google Apps drive. Log into our drive here. Log into drive here. Of login. See. Share it with me. Open share it with me. Sorry, wrongly login. Wrong mail ID. 1 second. NRA 222. Yeah, this is a mail ID. Should log in. 1 second. Just log into 2. Yeah, this is. Yes, log into your Gmail ID like this. Login. Of login. First login. Log into your Gmail ID. Yes, that registered Gmail ID with the online team. Okay. Yes, yesterday evening, online team has given Gmail ID. As per that, I have shared here. Yes, Gmail ID. Yes, after login to your Gmail ID, go to Google Apps. Google Apps. Google Apps. Google Apps. Open Google Apps. Here there is a drive. Drive. Here there is a drive. Google Apps from this drive. Drive. Go to Google Drive. Here there is a shared with me option. Shared with me. Shared with me. Shared with me. Shared with me. Yes, here you can see MNRAP core Java, right? MNRAP core Java folder. Double click, open it. You can see all. Double click, open. Yes, shared with me. Log into your Gmail account. Yes, log into your Gmail drive. Go to drive. Go to Google Drive. Go to Google Drive. Then check shared with me. Check shared with me. Open shared with me. Okay. Double click. Shared with me here. Is open here. Yes, MNRAP core Java. See that double click open. You can see all this software. Okay, yes, tomorrow it's a installation part. Tomorrow we are going for installation. Tomorrow going for installation. So right click, download. Downloading JDK. Right click, downloads. Right click, download like this. Now presently JDK 8. Next we'll see JDK 9 also. JDK 8, Eclipse, and your core Java documents. So these three you have to download it now. These three by tomorrow class download and keep into your system. We'll start installation. So JDK, Eclipse, and your documents. Okay. Next, shade with me recordings. See 9:30 a.m. recordings. Open that, you can see all that. Recordings. Right click on recording here. See here. Open with yes video player that playing. Open this, that will be playing here simply. Okay, so recordings type. Recordings type and material. Share it to almost all students. You can access from Google Drive. Simple way. Go to Google Drive, log in here, Google Apps, Google Drive. From Google Drive, share with me, share with me, share with me, share with me. You can see yes, that MNRA Core Java folder, MNRA Core Java folder, and MNRA Core Java 9:30 am. 9:30 am. These two folders you can see. These two you can see. That's here. These two you can see. Okay. Yes. From this you can download it. Fine. Okay. So here, so JDK, the JDK software not necessary. You need not download here. I have downloaded it. It's there in drive here. You can take from my drive. Yes, my drive I have shared with you. Just you can download from the drive here. Download from your Google Drive. I have shared to your Google Drive. Okay. So since JV is a OS dependent, JDK also OS dependent. So that's all about independent platform. Yes. Next, see exe file dot plus file. What is main difference here? Exe file links with OS library. Dot class file don't have any OS library. That's a difference here. Next, exe file statically linking with OS library. Dynamically, yes, dot class and dynamically file dynamically here. Okay, see the differences. Exe file dot class file differences. Exe dot class file difference. Exe file binary code dot class byte code. Yes, ex system understandable. Dot class byte code JV understandable. See exe file links with OS library. Okay, don't have any OS library. Exe file is a prepared for specific OS. Dot class is not a prepared. Don't have OS file here. OS library here. So OS library statically linking with exe file. So you can OS library dynamically linking with dot class file here. Okay, exe file prepared one already prepared directly running, but dot class is not a prepared file. Okay, yes. To prepare the JVM required. JVM prepares as per current OS. So dot class file not prepared file. After moving on to OS, JVM prepares as per current OS. That's it here. Okay. Yes. Exe file executes faster than dot class file. Reason here already linked, already prepared, faster. Dot class file is not a prepared here. It's a preparing at runtime. So dot class file linking with OS library at runtime. Dot class file linking with OS library at runtime. Since linking at runtime here, since dot class file preparing at runtime, it slowly executes than exe file. Not much slow, just little bit difference compared to exe file. Little bit slowly, little bit slowly. So the exe file dot class file differences. Yeah, that's all about introduction. So introduction complete. Yes, all is introduction, that services and all this here. Okay. Yes. Next, Java installation. Next topic is about Java installation. Yes, tomorrow we'll be going for Java installation. Tomorrow about Java installation. Yeah, that's all, guys. Any doubts? Yes, by tomorrow class, download software. Yeah, JRE also will discuss. As Amjad, JDK, JRE, JVM differences we'll discuss. Okay, we have JVM topic separately. Yes, JVM internals. JVM internals, that time I will explain about JDK, JRE, JVM. Okay. Yes, by tomorrow class, be ready with your software. We're going for installation. So once installation is done, from Monday onwards, yes, tomorrow itself, first example I'll explain here. Installing Java program, installing Java software, installing Eclipse, how to develop the first program. That we'll discuss tomorrow. So tomorrow starting programming. Okay, yeah. So that's all. That's all, guys. So thank you, guys. Yes, see you tomorrow. Tomorrow also same link, same time. Okay, 9:30. Same exactly 9:30. Okay, yeah, that's all. So thank you, guys. Have a great day.